Assalamualaikum and good morning everyone. This is our video for MAT183 for our group project, and let me introduce you to our group members. Alright, so let's get into it. Alright, so we will be going over question 1, which asks us about the meaning of differentiation and its techniques. Now, differentiation itself is a fundamental process within calculus that deals with finding the derivative of a function. To go in depth, so to speak, is that it measures the instant rate of change of a function with the variable of the function in mind. Now, about the techniques itself, so far as our lecturer has covered to us, there are 8 techniques that we have learned over. Now, first of all, constant rule, second, power, third, product rule, and third, which is the constant multiple rule. Next is the implicit differentiation rule. And after that, sum and difference rule, and then we have the quotient rule, and last of all is the chain rule. Now that pretty much sums up question 1, and we are done.
Assalamualaikum, my name is Irfan and I'm going to be doing question 2. Part A, we are going to be solving y equal 3x squared sec x plus 2. So to do this question, we are going to be applying the product rule, which is it is 3x squared. For the v, it is 3 sec x plus 2. We have to find the u prime and v prime. So to plug this equation into this formula. We are actually done, but we just need to simplify. Sorry, my bad. We actually have to. This is actually a u prime. So, followed by the next equation, which is we actually done here, but we just need to simplify this question and this answer. That is all for question 2, part A. Okay, for question 2, part B, we are going to be implementing the quotient rule, which is followed by dy dx equal vu prime minus u v prime divided by v squared. So in order to be implementing into this formula, you have to find the u and v. So once you've got all this, we just plug this equation into this formula. So we're actually done here, and we just need to simplify this equation. We are all done for question 2, part B.
Alright everybody, so and then for question 3, we were presented with y ln 3x minus exponential 2x plus 1 minus tan for y. So this question requires us to differentiate all of them. So what we're going to do is we're going to differentiate them one by one. So and then we need to bring up the formula, which is u v prime plus v u prime. And then we're just going to copy all of them. Okay, and then we're just going to put all of these values into the formula. So, and then we're going to differentiate exponential to the power of 2x plus 1. So, what we need to do is, first of all, we're just going to copy all of them. Copy the whole exponential, yes, which is e to the power of plus 1. And then we're going to take the power only, and then we're going to differentiate them, which will leave us with 2. Okay, because we differentiate the power. And then for tan, for this is it requires us to remember that if we differentiate tan, we get sec to the power of 2. You know what? Sorry. So 1, this is 2. Sec to the power of 2 with 4y. So after we're done with differentiate tan, we're going to differentiate 4y. So 4y, we get 4, and for y, we're going to get dy over dx equal to 0. We're going to rearrange all of them to get dy dx. So we're going to get the others, we're going to bring them to the other side, yes? We're done with that. We're going to take only dy dx. We are going okay, and then we're just going to we're going to let dy dx on this side. Okay, so we're done with that.
Finally, I will be solving the last question, question 4. This question involves in linear approximation that need you to correct to 3 decimal places to solve it. In this equation, it's square root of 80.99 minus 2 over square root of 80.99. You can solve this question by using the formula. And then, based on this formula, we need to find the value for x. To find the value of x, you need to find the number with a decimal point. For example, for this question, it's 80.99. Then, we also need to find x naught. You can find x naught by rounding the number. Then we need to find the dx by using this formula. Dx equals to x minus x naught. X is 80.99 and x naught is 81 and minus 0.01. Then now that we got the value for the x naught, we can put it inside the formula. Now we only need to find the f prime. To find the f prime, we need to differentiate this equation. But first, before you differentiate it, you need to find the function. You can find the function by let 80.99 as x. The function for this is square root of x minus 2 over square root of x. We can also simplify this term just like this. You may ask why is the second term is 2x to the power of negative 1 over 2. It's because the square root of x is actually put on top of the numerator. And finally, we can differentiate the equation without applying any rules because we can treat both of these terms as its own functions. Then for the final steps, we just need to complete this formula. We can do it by rewriting the fx and f prime x. Then we can just use the calculator to get the value. And finally, we can times it with the dx value. For the final answer, we will get 2.77671468, and then you just need to correct to 3 decimal places, and it's 2.778 as the final answer.
Okay, so that is all from us for this group project. Peace out.